Assalamu alaikum. So we are starting our new course, which is Advanced Quantum Mechanics. So today is our first lecture. So let's start. This course mainly depends upon two parts. The first one is non-relativistic quantum mechanics, and the second is relativistic quantum mechanics. What is the main difference between relativistic and non-relativistic? Uh, Relativistic basically means if the particle has speed compatible equal equivalent with the speed of light, you can say the particle is moving relativistic. Okay, so if your speed is compatible equals to the speed of light, then you are in relativistic. Okay, non-relativistic means it surely has speed less than speed of light, because nobody has speed more than speed of light. If it is equals to c, means speed of light, so you can say relativistic. If it is not equals to speed of light, less than speed of light, the value of c, you can say body is non-relativistic. So these are the two main parts of the quantum mechanics. So in non-relativistic quantum mechanics, there are more three sub points. The first one is we are dealing with single particle, the second is we are dealing with many particles, mean more than one, and the third one is we are dealing with scattering. Okay, so this is a simple table. So let's start. So from left to right, our mass variation is going, mass decreases, and from bottom to top our velocity got increasing. So I just divided my section into four parts. So here you see mass is high, mass is very decreasing, and here mass is very small. So first see this part. Here mass is very large and velocity is very small. So where mass is large and velocity is small, you are in uh, classical mechanics. So next to this, you see here mass got small, means mass is very small, and velocity is also very small. You know what is quantum mechanics? Basically, when you are dealing with small particles, so when mass is small, so here now classical mechanics converts into quantum mechanics. And why this is non-relative, why this is non-relativistic? It is non-relativistic because speed is smaller than c. Here you see speed is small, and here going speed is large, but here speed is small. As speed is small than c, so you can say non-relativistic quantum mechanics. Why? Because mass is very small. Comes up to this section, you will see here mass is very large. Moreover, velocity is also very large as comparable to speed of light. So when body speed equals to the speed of light, you are in relativistic. Why this is classical mechanics? Because you are here where mass is very large. Mass is very large, velocity is very large as compared to speed of light. You are in relativistic classical mechanics. Next to this, relativistic quantum mechanics. Why quantum mechanics? Because you see mass is very small and velocity is very large. So velocity is very large as compared to c, so that's why relativistic, because mass is very small. So that is quantum. Okay, so next move towards basically what is quantum particle. I already told you that quantum particle is a particle, the smallest possible amount of anything, means the smallest structure, like atom. Anything in this world made up of atoms. The dimension of atom is 10 raised to power minus 10. So this is the boundary basically. Okay, so mass greater than 10 raised to power minus 10 becomes we are in classical mechanics. This is the basically mass range. Bodies having mass less than this 10 raised to power minus 10, so we are in quantum mechanics. Okay, quantum physics, quantum world, because atom has a dimension of 10 raised to power minus 10 meters, means this is a mass of atom. So we can say atom is a quantum particle. So we can also say that everything in this world which are made up of atom are quantum particles. Okay, the dimension of nucleus is 10 raised to power minus 14. Similarly, inside nucleus, nucleons, that are neutron and proton, dimension is 10 raised to power minus 15. And inside these nucleons there is quarks, and the dimension of quark is 10 raised to power minus 18. Okay, this is much smaller than 10 raised to power minus 10. So we can also say nucleons, quarks are all quantum particle. So this is the basically range of classical to quantum physics. if mass greater than 10 raised to power minus 10, so we are converted to quantum to classical. ठीक है. Next, there are two things, discreteness and continuous. What is continuous? Continuous basically random, means continuously. In continuous system there is a range given, means 0 to 10. There must be a number between 0.5, between 0 to 10. So this is continuousness. Okay, what is discreteness? Discreteness means discrete, fixed values, fixed state, either 1, either 2, either 3, either 4, either so on, but not inside these state, not 1.5, not 2.5. These are between 2 and 1. No, this is not. If this is continuous. If there are fixed state like 1, 2, 3, 4, so this is discreteness basically. Okay, so the next thing is, at low energies you are in quantum mechanics. As you are moving up top, your energy level increases. With your energy levels, along with your energy levels also go closer to each other. You can see here how close energy levels are there when you are moving from low energy to high energy. And once you move from low energy to high energy, you are converting your state from quantum mechanics to classical mechanics, because in classical mechanics energy is very very high, but in quantum mechanics energy is very very low, and particle is also very small in quantum mechanics. Okay, less than 10 raised to power minus 10 meters. So once you are in quantum mechanics, you are probabilistic. What is meant by probabilistic? Probabilistic means you have just a probability that either your thing is here or here, because quantum mechanics, quantum particle is very very small, it not be at rest. So this is my pen. Let us take an example. This is on a page, because this pen is a classical pen, classical thing. This is not a quantum thing, because this has mass 2 grams, 5 grams. This is not smaller than 10 raised to power minus 10. If if this pen has mass smaller than 10 raised to power minus 10, then this is a quantum pen, otherwise not. For now this is my classical pen. So classical mechanics is deterministic. What is meant by deterministic? Deterministic means you are fixed, you are authentic on this point that this is confirmed on that page. Okay, so but in quantum mechanics you are just probabilistic, because quantum mechanics particles are very very small, they are not in rest. So in random time particle move from here to here, sometimes here, not on a single part. That's why you can say our quantum mechanics is probabilistic, that there is a probability. You cannot fixed, you cannot say that this quantum particle is perfectly there, because quantum particle always changes their position in a single nanoseconds. So because they changes their position, so you can also say that you cannot localize your quantum particle. Localize means fixed location. So there is no fixed location in quantum mechanics, there is only a probability. So next move, there is a thing like wave function. What is wave function? Every quantum particle in this world have a wave nature, means everything in this world are associated with a wave. This is my pen, and what is the building block of this pen? Means this pen is made up of atoms. Atom has a dimension 10 raised to power minus 10. So this pen is basically, you can say, made up of atoms. So that atoms are quantum particles. So you can say that atoms are continuously emitting what? Wave. Okay, every atom in this world emitting wave. They emits, they radiates wave, and this is called wave function of that particle. And wave, you already know, has two main features. One is the amplitude, high amplitude, low amplitude. What is meant by amplitude? you already know that highest peak lowest, so this is my graph, this is my amplitude, this is the max point. Okay, so this basically amplitude. And what the next thing, wave function tells us about the phase. Phase means direction, either particle is moving right side, either left side. Okay, so let's suppose a classical wave that e की power iota kx minus omega t, exponential iota kx minus omega t, along with iota kx minus omega t. Kx minus omega t is my phase, means it's my angle, it's tells us about the direction. And what is this? A basically tells me about, this is basically the amplitude of my wave. Okay, so the last topic or thing which we discuss in our lecture number 1 is black body radiation. What is meant by black body radiation? Okay, so basically two scientists work on this. The first one is Wien and his law, called as Wien's law, and the second one is Rayleigh-Jeans and his law is known as Rayleigh-Jeans law. Okay, so first what tells Wien? Wien and Rayleigh-Jeans both do experiment. They took quantum particles with energy E, and they have a wavelength of different particles, and they plot experimentally and they get this graph. So here your energy is 0 and wavelength is 0. As you are increasing your energy, your wavelength is also increasing. Okay, but there is a max point. If you increase more wavelength, means particle which has more wavelength, their energies go low. Okay, because you know the relation E equals to hc by lambda. If you increase the wavelength, energy must decrease. So if you increase wavelength, you see energy must decrease. But what Wien tells us about? Wien basically tells us about the nature of particles at lower wavelength, particles which has low wavelength. But Rayleigh-Jeans tells us about the energies of those particles whose has wavelength large. Okay, so these are the energy density formulas for Wien's law. A mu cube exponential minus beta mu by t. And what is the formula for Rayleigh-Jeans energy density formula? 8 pi mu cube kbt divided by c cube. Okay, so these are different formulas for this, but you can say when Rayleigh-Jeans, it's important point that Rayleigh-Jeans are also known this as ultra-violent catastrophic. Why? Because Rayleigh-Jeans give us a concept at higher wavelength. So particles which has low wavelength, they are distorted. So Rayleigh-Jeans said ultra-violent catastrophic. Catastrophic basically means distortness, tabahi. So there is a distortness at classical physics, means particles having low wavelength towards distortion. Okay, so this is our first lecture. Tomorrow we will do our second lecture of advanced quantum physics. This is a very interesting course, so you must go through these lectures. I should upload this on my website, so stay connected with us. Okay, so we will also start our next course series in